Welcome to Vision Plus. We are looking at domain and range of quadratic functions in the vertex form. Example 1 says, find the domain and the range of the function f of x equals to x plus 2 close squared plus 3. Remember, I'm using always here domain and range. And in the introduction we said domain is also called the object values or the input values of the function. And we also said the range is the set of the output values or the codomain or the image values of the function. Please do not forget that these two terms have other names. Coming to our solution for this, we have said domain is always a set of all real numbers as long as it is a quadratic function. In whatever form, the domain is always a set of all real numbers. All real numbers. That is the domain, which is the object or the input values of the function. And in the interval notation, our domain is a set of the values of x from negative infinity up to positive infinity. That is a set of all real numbers. In the set Bueller notation, our domain is a set x for which all the entries are real numbers in that manner. So this is the domain in the interval notation and set Bueller notation. Let us go now to the range. Our range, we said our range depends on the value a and the y coordinate of the vertex k. Let me state the function in the vertex form. F of x equals to a into x minus h squared plus k. Now let us compare the given equation to the vertex form. On comparing, our a corresponds to the coefficient before the bracket here, that is 1. So our a is 1. Our h on comparing h of the formula to the given value, our h is negative 2 because the formula has a negative. So if the general vertex form, if the vertex form has a negative but the sign here has changed to a positive, it implies that the value of h was a negative number. So h is a negative 2. Our k is positive 3. That is simply 3. Now, from here, what do you see? We can see clearly that our a is 1. That means it is positive. We said if a is positive, if a is positive, then our range y is more than or equal to k. So we don't need to even look for k because k is given in the function already. K, which is the y coordinate of the vertex, is 3. So simply, our task here is to identify A. We check whether A is positive or negative. If it is positive, like for this case, our Y is more than or equal to K. Therefore, our range Y is more than or equal to K. What is K? 3. And if A is positive, we have said, if A is positive, it means our curve has a minimum turning point. But I will not go into that analysis for now. What is very important is identifying K, identifying A, telling whether it is positive or negative, and then you state the range accordingly. So I believe you know how to interpret inequality symbols. This is the range, correct? But what about the range in the interval notation? Our range is a value Y is more than or equal to 3. That means Y starts from 3 and it becomes bigger than 3. That is, the numbers more than 3. So our range starts from positive 3 inclusive. So you put here a square bracket and then it increases or above 3. That is, it increases to positive infinity. So this is the range in the interval notation. Or someone can say that, okay, the range comes from positive infinity and then it stops at 3, with 3 being inclusive. So the two forms or the two formats are formats of the interval notation. What about in the set Bueller notation? In the set Bueller notation, our range is a set Y for which all the values of Y are more than or equal to 3. So the values of Y start from 3 and above, or they come from positive infinity and stop at 3. So this is the solution to example 1 when we are looking at the vertex form. We shall be going to example 2. Thank you.